In this problem, we're given that the sine of x is 1/5, and we're asked to find the cosine of 2x. We're also told that cosine of x is positive. So since sine is positive and cosine is positive, this is the problem's way of saying that x is in quadrant 1. So here we have x is in quadrant 1. Sine is positive, so it's in x is in quadrant 1 or quadrant 2. And cosine is positive, so x is in quadrant 1 or quadrant 4. The only one they have in common is quadrant 1. Might be relevant, might not, but that's what we're being told. That's why that piece of information is there. We have multiple choices for what we want to, where we want to get the cosine of 2x. We've got 3 different double angle identities for cosine. Cosine of 2x is cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared, all related by Pythagorean identities. Since the information that we have is sine, we want to use the third one. So we're given information on sine, so we should use that one. So in this problem, we'll have cosine of 2x is 1 minus 2 times the sine of x squared. So we'll just take the 1/5 and drop it in there. We're using that one because we're given that sine of x is 1/5. So if we want to use the other ones, we have to go out and figure out what cosine is, which we totally can do, which you're probably predicting that I'm going to do anyway. And you would be correct. But let's, since if we remember all 3, we can just use this one, 1 minus 2 times the sine squared. So we have to square the 1/5. So 1 minus 2 times a 1/25. So that's 1 minus 2 25ths. And that's 23 25ths. We can just take this mixed number and turn it into an improper fraction by 2. 25 times 1 minus 2. Or you can do the same thing, get a common denominator between 1 over 1 and 2 over 25. So since we know that sine of x is 1/5 and we're in quadrant 1, we could read the sine of x is 1/5 as opposite and hypotenuse. So it could be that the 1 is opposite and 5 is hypotenuse. And we can draw a right triangle in the first quadrant with those details, where x would show up down here, opposite is 1 and hypotenuse is 5. Then the adjacent side, the adjacent squared plus the opposite squared is the hypotenuse squared. So the adjacent side will be the square root of 25 minus 1, or the square root of 24. That would mean that cosine of x is adjacent over hypotenuse. Now that we have cosine information, we could take two of these square root of 24 over 5s squared minus 1. So this is going to be 48 over 25 minus 1, and 48 minus 25, 24. We could do the same thing. 25 times negative 1 plus 48 is 23. Although if we're going through all this trouble of finding cosine of x from the sine x with a little right triangle, that's probably because the only one that we remember is cosine of 2x is cosine squared minus sine squared. So maybe we're doing this. Square root of 24 over 5 squared minus 1/5 squared. So I got 24 over square root of 24 squared is 24 over 5 squared, which is 25. 1 squared is 1 over 5 squared, which is 25. At least they have a common denominator now. So in all three cases, we end up with 23 over 25, which is good. If one of these was different, then something is going to be wrong. If your answers don't match, then something is wrong. Since there's three of them, if you did all three and only one of them didn't match, then probably that's the one that's wrong. Although it's possible that you did one right and the other two wrong, the exact same. It's just less likely. Any questions? How's everybody okay? It's funny, there are certain things in math, when you're a math teacher, you notice certain things go through cycles. And recently, the Monty Hall problem had come up again. Anybody familiar with the Monty Hall problem? Anybody familiar with The Price is Right? So there's a game show called The Price is Right, if you're not familiar. And one of the games is that you're presented with 3 doors. And behind one of the doors is a fabulous prize, and behind the other 2 are non-prizes. Usually it's like, oh, behind one of these doors is a brand new car, and behind the other 2 doors is like a goat. Now, this is be completely ineffective against certain people. Because if my wife went on the show and won a car, she'd be disappointed knowing that she could have had a goat. They don't actually let you keep the goat. It's like a non-prize. You don't actually get the goat. That'd be totally how I acted. I'm like, oh, take door number 2. Oh, it's a goat. I go, yes. What's his name? It's like, oh, what? He doesn't have a name. It's like, oh, he does now. You will be Billy the Goat. And Billy the Goat would be like, oh, that is such a typical name. You are boring. I'm like, oh, that's right. But you're coming home with me. You'll get to meet my dog. Is it? I don't know. So the game goes like this. There's 1 prize door and then 2 non-prize doors. And all you have to do is pick one of the doors. And so you pick one of the doors. You say, I'll take door number 1. And so since you've taken door number 1, I'm going to show you what's behind door number 2. And then behind door number 2, it's like, oh, you didn't pick the goat. Now, do you want to switch to door number 3? Or do you want to stay with door number 1? That is what, yeah. And then the question for the Monty Hall problem is, what is the probability that you win if you switch? And for the most part, people say 1 and 2, because there's 2 choices, one of them is correct. And this is not the case. The strategy should be to switch. If everybody switched in that scenario, that would produce a winner 2/3 of the time. If you never switch, that produces a winner 1/3 of the time. And for the most part, people say it's half and half because there's 2 choices and you're picking 1, but that's not where the game started. When the game started, there were 3 doors. It's a 1 in 3 chance that you get it wrong. They take away the door that is definitely wrong. So it's a 2 in 3 chance that the other door is right. So switching in the long run is better. It's better overall. It might not be better for you. You might be the 1 in 3 that had it right the first time and you switched off the correct answer. Right? And the idea is, I think psychologically that feels worse than not switching and losing. Right. Right. Because it's car, goat, or well. So let's say you always pick, let's just say you always pick door number 1. I'll do it this way. Let's suppose that you always pick door number 1. If you pick door number 1, you were right 1/3 of the time. But then what happens is I show you one of the other doors, right? I show you so you pick door number 1, you had the car, I showed you the goat, you switch, you leave, right? But here, there's the goat. You picked the goat. You don't know this yet, but the car was behind door number 2. I'm not going to show you that one. I'm going to show you this one, and I'm going to take this one out of play. Here, it doesn't matter which one I take out of play. It doesn't matter. But here, since you got it wrong, I take the other wrong answer out of play, and switching produces a win. In this third scenario, the same thing happens. You picked a goat. I'm not going to show you the car. I'm going to show you the other goat, and I'll take that out of play. You have more information after one of the doors has been opened. And so here, a switch produces a win. So of the 3 possibilities, switching produces a win. Staying, and only one of the possibilities, switching produces a loss. But for the most part, people only analyze this problem starting here and saying it's a 1 in 2 chance, but it's not a 1 in 2 chance. You have more information. There were 3 doors to start with, and you know which door it isn't. So, up here, it didn't matter which one I took out. Switching, it still produced a lead. Any questions? It's the Monty Hall problem. This is not an opinion piece. Anybody who says that the probability is 50-50 is in fact incorrect. And it does not matter that 1/3 of the people are losing when they switch. Because in the long run, some people are going to lose. That make sense? This is important shit. Because this is the kind of stuff that shows up and people have very strong opinions about. And they have very strong opinions about something that they were super wrong about. 0.9 repeating is equal to 1. There is no debate. This is not an opinion. There's no question about it. It is a fact. 0.9, and infinite, all the 9, an infinite number of 9s, that is no different than 1. See, and it doesn't feel good, right? It's just like the Monty Hall problem. Because if you're in this first category, switching sends you to a loss. You had a win, but you threw it away by switching. But that only happens 1/3 of the time. It is, it's equal to 1. They're exactly the same. They're no different.
Then why isn't it one?
That's a good question. If you have 0.9 repeating, you should just say 1, because they are the same, and you'll never be wrong.
No, the point three is saying, you can't divide one by itself.
It's not smaller than 1. 0.9 repeating is equal to 1. Yeah. Also, if someone writes down a proof that 1 is equal to 0, they at one point divided by 0. It's always dividing by 0. It's so boring. It is the most boring proof that 0 is equal to 1. At some point, they divided by 0. They say, oh, just multiply, or they multiply by 0. Either way. Oh, just multiply by a minus b. A minus b is equal to 0, dumbass. Multiplying by 0 doesn't show that anything is equal. 4 times 0 is equal to 5 times 0. Is 4 equal to 5? No, you can't divide by 0. So knock it off. But they try to do it in a hidden way. Oh, look, nothing up my sleeves. Now just multiply by a plus b, and then, or a minus b, and then quickly move on from that. And that's where you call them. You just wait for them to say, now multiply by a minus b. And you say, stop. I object. That's when you object. Get your hair, get ready when you see it coming. They're going to say multiply by a minus b. So get your hair in the anime form. So you can do like the lawyer. Say, I object. Multiplying by 0 doesn't prove anything. You know what I mean? Yeah. Misinformation and disinformation. And we can't tell the difference. Because people are trying to stop you from learning math. It's all variations on wrong information. I don't know. Is it real information? I guess it's information. It's information about the person doing the communicating. It's all true. All right, that's going to do it for today. That's going, and I think Thursday is a flex day. All right, so that's it for today. That's it for this week so far as trigonometry goes. You can send me an email on Thursday, say, haha, you're at work and I'm not. Thursday's a flex day. Thursday is a flex day. So that's it for today. That's it for this week. I'll see y'all on Tuesday. Everybody have a good weekend and thanks for playing.